Hey everybody, this is Larry. This is me over Q4 of the weekly contest for 23. Count K-Reducible numbers less than K. Or less than N, my apologies. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So the first thing to notice is that when you read this problem, when you understand it, is that, well, you have this like input that's kind of weird, right? It has 800 digits, but binary digits. But the key thing to note is that, of course, that means that the most number of ones that it can be is 800, right? Because if you have 800 ones, and that's basically the input, after one operation of this thing, after one operation, it'll be at most 800, right? So that means that after one operation, even though you have this huge number, it'll go down to at most 800. The thing that fooled me a little bit was that K is small. I thought maybe you have to optimize on it, but it really just turns out that you could go from a 2 to the 800 number all the way down to 800 with just one step. So you, after 5 steps, you always get all the numbers. But I wish that they didn't have this, because then now it would disguise it a little bit more, and it doesn't really change the code for me anyway. So it's just kind of, I don't know. I was like, maybe there's some like weird, crazy brute force thing with K, but it turns out this was actually irrelevant. But yeah. So you have all these ones, and the idea here for me, you have to go with, it has to be strictly less than, right? So the way that I did it is just by converting this to a binary number -1, and then converting it back to binary, right? I have a fun fact for you, but I'll save it for the end because it's not that important for to understand this problem. But yeah. But basically, all I do is just subtract 1, so that now instead of strictly less than, I could do less than or equal to, right? And that makes some of the digit dynamic programming a little bit easier. Oh yeah, because of that silly mistake, I actually re-recorded this. I forgot to say that. For me, for this one, I did it in about 16 minutes. It is digit dynamic programming, what people call, I don't know, I'm not a fan of the naming, but in any case, it is how you solve Q4 of the bi-weekly contest. It is the morning contest for me, but not everyone. Yeah, you may be from a different time zone, so it's not necessarily the morning. But yeah, so that's why I'm a little bit like, it was very fresh on the mind. But yeah, so then now here, I think this part, hopefully everyone can come up with at the very least. And I did use some Python magic, but you don't even need to, right? You can calculate this very quickly. Again, I just did n plus 2 just in case, but given that length is at most n, that means that s has at most n ones, and that means that and lookup sub I is just the number of bits in I, which I didn't even really need to look up now that I kind of look at it like this, but I think that's fine. But actually, did I even use it? No, I did. I forgot about I was going to use it in like a breakfast search or something like this, but it turns out that I did it here with. So actually, I don't even need it because I didn't even use it. I just because it was so easy that I just wrote this thing instead of, because I think the way that you probably want to do it is something like this. And in this case, if the function is a little bit more complicated, you can kind of construct this dynamic programming in that way. So, but here you don't even need it. I forgot that I did it without thinking during the contest. This is contest code, right? So now, okay, so then maybe I.bit count is the number of bits in I, right? And then now steps of I is just building off, steps of I is equal to steps of I.bit count plus 1. And now I'm just writing comment that is exactly the code. But the idea here is that, okay, well, what is the, how many steps does it take to get to I.bit count? So then now the next step is going to be from I to bit count. So then you just, do this from 1. And this is, I guess, dynamic programming. This is the same across all inputs. So you can pre-process this, but it's also not a big deal because n only goes up to 800. So an extra 800 operation isn't going to kill you usually. But it is Leetcode, so maybe I'm wrong. Who knows? But yeah. And then here's the brute force version of it, right? The way that I did it. Maybe there's a little bit smarter way of doing it, honestly. But I thought that the math or the math with respect to the complexity is fast enough, and we'll go over that in a second. But basically what this is saying is that, okay, so let's say we start. Yeah, so let's say we start with a number that goes to I, right? And what I mean by that is goes to I is because now for every number you do one step, one operation, right? And doing one operation just now counts to, yeah. After one operation, we now have buckets of numbers that maps to number of ones, right? So that's basically the idea. Number of ones, right? So here we go, okay, so and the way that you can really think about it is that if you want to keep it as k, at most k, then it's steps plus 1, because then now steps of I is going to steps, but one of the step is going from the initial input to I itself. So if this is the case, then yeah, if this is close enough, then we just count out, okay, then we have f is the number of numbers that maps to I number of ones. So that's really the idea, is that we go, okay, the numbers that are one step away from I, are they good? If they're good, then we count how many there are, and then the number that we count, we just total them all together, right? And that's really the idea, and that's pretty much it. And yeah, and then now you have this dynamic programming that gets the count, right? So what is the idea behind this dynamic programming? For this particular video, I'm not going to go over the nuances of dynamic programming. This is a hard problem, so you know you should be familiar. So I'm not going to go over that deeply. But index is just the current index of the input that we care about. Or like another way to say it is also like we finish the prefix of the index, and then prefix is the same thing as digit dynamic programming. It's just that whether we're matching the prefix until now. And I'm kind of skimming over this part, but I shouldn't. But the idea here is that, well, now we have, for this problem, we have to consider smaller than some than the input, right? And the way that I think about it, there are really two cases, right? And maybe they could be two different functions anyway. But the idea here is that, okay, so there are two scenarios, right? So let's say you have this number, like it just looks like something funky and weird, whatever, right? And then the idea is that you want to get all the numbers smaller than this one. Well, for every digit, like let's say we only process 2 digits, right? And there is and let's say we match this, right? Let me add a 0 real quick. So let's say we have these numbers, and then now we have to figure out how many the count is there to the rest. So this is where the index comes from. The prefix is just basically whether we are matching or not, right? Because, for example, actually maybe this could be a 1 and this could be a 0. Right, and then the next number is 0, right? So, well, what happens? What happens is that because we match the prefix, that means that the rest have to be matched or smaller. So that's all this is saying. Because here, because the digit is 0 and we match the prefix, this could be a 0. What does that really mean? Well, what that really means is just that, for example, a different input, let's say the prefix are not already matched, or we already got something smaller, so that means that the prefix is smaller. If the prefix is already smaller, maybe that's another way of thinking about it. If the prefix is smaller, then x doesn't have to match this. X can be either 0, the rest we curse on, or it could be a 1, right? And it doesn't matter that this 1 could be greater than 0 because, well, because the previous digits are already smaller. So that's the way to think about it. And of course, if you have an alternate case where this is a 1, even if you have a prefix, then now, of course, if you kind of consider this case, this x could be 0 and or 1. But of course, if you have a 1, then the rest has to be prefix identical. For 0, then the rest is not. So actually the rest can be whatever you want it to be in this case as well, right? So that's, I mean, I'm going kind of fast, but that's really the idea for this particular digit dynamic programming, what prefix means, right? And then left is just the number of ones we care about. And maybe and I think actually, honestly, now that I think about it, there is an optimization that you can do with counting the number of ones. I mean, this took about 3 seconds, which is fine. Maybe I could have optimized it though. And what I mean just by that is a little bit of a pruning. That doesn't change the the thing, which is that if the number of possible numbers left, so actually you can just remove this and do like n minus index is the number of numbers left, including this one, right? So because with index is 1, or there's n minus 1, you have 1 number left. I think maybe it's either this or it's off by 1. So okay, well, oh no, it's the other way. Oops, of course, right? Yeah, okay. So you can actually prune this as well a little bit more. This is a superset of what I just had. So yeah. Well, Leetcode difficulties, and you can see that this is much faster. I mean, at least on Leetcode terms, an extra second. But yeah, but the other solution is also true, right? And it's just for pruning, because it's just basically saying that, okay, you have no, you need this many ones left, you have this many digits left, so if it's greater than, then it's just, there's no possible way to make up the difference. Anyway, so then now you have the two cases where either a match or it doesn't. If it's match, if this is 0, then you only consider the 0 because you already matched it. Otherwise, then now we can do a 0, and again, now it no longer matches. And yeah, otherwise when you have a 1, and you have 1 to subtract from, then you just do a left minus 1 from this, right? So pretty good. In this case, if the prefix is not matched, then you just do both. You try both 0 and 1, keeping in mind that you have to do, you just have enough to subtract from. Not a big deal. Though you don't even technically need this if statement, because this will calculate it for you if you really want to think of it that way, because it will just return 0 early. If you really want to just like, it's actually the reverse of optimization, but it's just a little bit cleaner in terms of understanding, maybe, right? Yeah. But either way, it's fine. So yeah, as you can see. But yeah. And then of course we remember to modding it, and that's pretty much it. So this is the dynamic programming, and yeah, relatively good, right? So what's the complexity here, right? Well, index can go up to 800, as we said, because after one iteration it'll be at most 800. Left can be at most 800, because you can have at most 800 ones, and then prefix is just binary, right? So true, false. So this is just 800 square, and that's going to be fast enough, right? Roughly speaking, times 2, say, right? Yeah, and that's pretty much the idea for this one. And yeah, because this is linear O of n, this is linear O of n, so yeah, and then we just kind of sum it all up, the number of numbers that are smaller than it, and that's pretty much it. And remember to mod, of course. We don't have you can mod here if you like, but you're only adding 2 numbers that are modded already, so that's why you can just save the number of mods here. But I always just do because why not? Oh, the one time that I did forget I got a wrong answer. I was like, oh, because I missed it in one place. But so I don't know. You never know. But yeah, that's all I have with this one for now. Fun fact is that fun thing about my solution is that this is actually my contest solution. Without the changes that we made. Okay, maybe I could get rid of the comments. The fun fact is that during the contest, technically speaking, my solution is imprecise. It's not wrong because I think it is exactly the same. But I while doing the first version of this video, I noticed that I was like, oh, wow, I did this wrong, but it still works. Why? And then I kind of dug into it. And the reason why this And the key difference is that we have this one here versus the binary version of this one, which I have here, right? So this is my contest code, and the reason why this still works is just because I got a little bit lucky in two things, right? Because the reason is that since S is a binary string, I convert this to an 800-digit decimal number, but I subtract 1. And the reason I did this is so that I could get I could do less than or equal to instead of less than. So this is a fun thing, right? But I did it wrong because I did it in decimal instead of binary. So that's very sloppy. But the reason why this worked and I submitted, otherwise if it just didn't work, I wouldn't submit it. I don't know that it would. I think this would have caught it if it was wrong. But the reason is because I never checked for ones. I only checked for zeros. Like in this case, I checked for zeros. And so it doesn't matter that these are ones, because basically what happens is that and it's kind of funny. I don't know. I find it amusing anyway. Is that, but sometimes you solve enough problem, you get a little bit lucky sometimes. Usually not, though. Is that in here, if you subtract 1 in binary, it becomes this, and in decimal, it becomes 999. But it doesn't matter that these are 9s, because all I care is that they're not zeros. So that's why this kind of works. And you could even imagine like a bigger number, like right? It goes to, instead of 1. Or actually, no, 1001111, I do 100999, and the 999 again doesn't matter, so that's basically it. I have 0, 1s, and 9s, but I only care about whether there's zeros or non-zeros, which is what I have in my code. So that's why it worked. So it's just a little bit of a fun, silly, lucky thing. If you watch, if you look at my submission, you could still see that here. So it's just kind of amusing. But yeah, but going back to this one, that's all I have. I'm gonna make this slightly smaller so you could see most of the problems. Here's the steps. Here are the inputs, right? For the digit dynamic programming, and these are just summing up all the possible ones. I think maybe there's a way to do it without doing it this way, but 800 square was fast enough for me. I don't know if there is, but yeah, that's all I have for this one. Let me know what you think. Thanks for watching. This is n square time and all of n space from here. I think one more thing is that if I needed to, you can do a space optimization, keeping in mind just noticing this, right? Because yeah, you can or index depend on is index +1, so you can rewrite this as bottoms up and then do the space optimization. I kind of did that in Q3, so you can check out that video for a different problem, but it's the same idea, right? But yeah, that's all I have for this one. Let me know what you think. Thanks for watching, and you can watch me solve it live in the contest now. That's fine. YOLO. Okay. How many pills got in it? 169. I was so slow on that, off by 1. That's just sloppy. How many pills got in this one? 23. So let's finish it. Another mod thing. Let's do the mod song. Mod. Okay. Sloppy today. 2 AQ. A lot of people AQ actually. Okay, focus. Just slow today, but that's all. Give it a binary string S, what's the number? Binary string S. Represent the number n. Okay, this is 7. Constraints are smallish. Focus. Okay. Replace x with the count on the set bits in the binary thing. So what does S mean? Why less than? Why are you giving the binary string though? I mean, I guess it can be long. I guess that's it maybe. But it's a little bit awkward. Okay, so then now we focus. I mean, it's just DP, right? Maybe. I don't know. 800. Well, 800 means that, I think what it's telling is that after one operation is 800, so you could calculate on 800, right? So then it's just a number of numbers that are right? That are less than n. K, what's k again? At most k times. Okay. And it doesn't include s for some reason. Okay, so still trying to think about how to think about it. It is the number of numbers with bits starting after. Okay, so then. So basically, it's just count the number of things. Right? And that's just like a bitwise DP thing, right? So, okay, so then now we want, what would a bitwise DP look like? We want a mapping to after 800, right? And that's fine. We'll pre-calc this. Oh no, it's just this number of ones, right? So if we have 6, goes it to 2. So that means that this is just I time bit count, right? Something like that. So then 1 goes to 1, 2 goes to 1, 3 goes to 2, that makes sense, 4, okay. And then now we have to do the inverse thing. So this is the transition graph. Okay, that's fair enough. And then what is it, a good way to bitwise operation? Yeah. So maybe it's going to be so index, prefix, and that's maybe it. And then maybe left for number of ones we care about. Okay, yeah. Remember the cache, Larry? Yeah. Yeah, okay. went over. And then now the prefix, right? So, okay, so we follow the prefix. I guess we can just do it this way, which is kind of yucky, but oh, whatever. So if it's 1, then we just kind of keep going. Otherwise, we go. We follow the prefix. This is left -1. Well, we're trying to go smaller, right? Okay. Yeah. Smaller or equal to, because we can just subtract 1 from this. Something like that. Okay, so then now if this is 0, then we keep the same, and that's it. If this is 1, then we keep the same, or we go lower, right? We keep the same with the prefix, or we go lower. Okay, otherwise if it's not prefix, then now every number is smaller, so then we just do this thing. Remember to mod Larry? Okay, fine. Right. And then now we just go we try the number of bits, which just goes from 0 to n plus 1. Zero, true, I. Okay, just for science. I think we're close, maybe. Okay, so there's 1. There's 3 of these. Oh, 3 being 1 is 1. Oh, no, because it's subtracted by 1. Okay, so then maybe. Oh, this is the next one anyway. That's what I was gonna try. Okay, so 8. Yeah, and all the zeros one don't really make sense. You can't do 0 because it has to be positive. So this would only go from 1 anyway. Alright, I think we're in a good place. 52 people already gotten it. Just slow on the earlier problems. Okay, do we care about zeros? Nope. So we have 3 numbers of set 1. Right, can we try a little bit bigger? I mean, the K doesn't really matter. I don't know why K is so small, unless maybe that's part of the problem and I don't expect it. I don't value it. Is this right? It's probably right, right? 1, 3. Oh, but I'm still trying, like, I need to try like random numbers. Let's say 5. I mean, okay, this is fine. But okay, so this is 6, so it's 1 to 5 inclusive, right? 1 to 5 inclusive. We have 1, 2, 3 is 2, 4 is 1, 5 is 2. So 3 and 2. Okay, so I think this is right. Okay. I'm just not confident about it. Okay, fine. So then now we have this thing, and then now how do we solve the rest? We have this k equal 5 thing, at most 5. And so we have this bit count thing, right? So then now we want to say, yeah, I mean, I don't know. We can just, we don't even, I mean, I think we can be a little bit smarter, but I don't even think we have to. So we have this thing, right? So then now, how many steps do we get? Okay, maybe we'll be a little bit smart, but yeah. So for I and range from 1 n plus 1, steps sub I is equal to steps of I bit count plus 1, right? It could even, this should be an array, honestly, but okay, fine, Larry. Okay, so then now, if step sub I is less than or equal to k, maybe I'm off by 1. F is equal to this, right? None type. Oh wait. Steps of 0 is equal to 0. Oh no, steps of 1 is equal to 0. So is this right? No. F is equal to this. This feels like it should be right. Did I change anything? So the answer should be 3. My answer is 6. Why? Tell me why. I, steps of I. F, okay. Why not? We're close though. We should be done, hopefully. I said that last time though, so I don't know. It's okay, so the 3... One is 0 step. 1, 2, and 4. At most 1 operation, right? Replace it with the count. Oh, okay, I see. So this is like strictly less than then. 3, 6, 0 is right. Okay. Am I good? Let's try at least a big number first. S is equal to 1 times 800. That's kind of slow, honestly, but maybe not. 800, true or not. What is that, 9 seconds? What is this cache clear thing that people tell me to do? Okay. I just do like something like that. Is that different? Is that faster? I guess it's slightly faster. Or is it just variance? Alright, I mean, I don't know. Maybe it's fine. But, YOLO! No silly mistake, please. Well, it's too late for that. So we'll see. Don't time out, please. Okay, thank you. Whew, 100 odd to kill. I mean, you know, we did okay, I think. I mean, I probably could have been faster, but I don't feel that bad about it. 4019 is right now. Oh, actually. Yeah, I mean, and so at worst, I don't know how updated this is, so I don't know actually. But maybe top 100, maybe that's fine. I mean, I definitely could have been faster, but oh well. Yeah, I was trying to slow it down a little bit, but maybe a little bit too much. No wrong answer though. Yeah, my Q3 I definitely could have done a little bit. Oh, 78. Oh. The auto update is kind of nice, but I prefer to auto ref or manual update. Like I wish you can turn it off, but that's fine. I mean it can go down, right? Because I have no wrong answers, which is nice. But I probably could have been or should have been a little bit faster on. I don't know, Q4. I feel like I was very careful. I think the thing that got me honestly is the K part. Because I thought K would be like the way that I did it, as you see, there's no reason why K could not be bigger. The Empire's okay. I mean, I also obviously got like some off by one things, but I don't know if this does anything honestly. Let's take a look at the running time. 3 seconds is okay. I'm just curious, so I don't know though if it's. Oh, I don't know what I did. We can also give it some there. I'm just curious for a timing thing because people always tell me about cache clear. Oh, so it was necessary. Good job, whoever told me to do a cache clear. That's a crappy thing. Like that should not be a thing that fails. I mean, in the past, yeah. I mean, I don't know. It is what it is. I guess shout out to people who tells me to cache clear. There are a couple of you. You know who you are. But yeah. This is pretty tight though. What I mean by that is just that yeah, I mean what I mean is that this is pretty dense, it's not sparse. So I don't know. Clash clear though. Otherwise I would have complained it again. It is what it is. Thanks for watching everybody. Hit the like button, hit the subscribe button, drop me on Discord. Let me know what you think about this problem, this contest, the explanation, everything in between. Whatever you like. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.